Hello everyone, today I'm gonna teach you how to use OPTIMOOR mooring analysis computer program. I'm Servando Garcia and let's do it. First I'm gonna start reviewing some useful terms that you all probably know if you're looking how to use this software, but I find this review useful just in case some of the terms that I'm going to use are not familiar to you. So first, the draft is the distance from the waterline to the keel of the vessel. The freeboard is the height of the ship deck above the water level. The depth is the sum of both distances. Maybe you are understanding these terms in a different manner as I'm describing them here, but this is how OPTIMOOR takes them into account. So heave is this vertical movement of the vessel. Roll is this turn around the longitudinal axis. LBP is the length between perpendiculars. It is the length of the vessel along the waterline from the forward surface to the stern or main bow. So is this distance that appears here. Yaw is this movement around the vertical axis of the vessel. Sway is this displacement, transverse displacement of the vessel. Pitch is this movement around the transverse axis of the vessel. Surge, longitudinal movement of the vessel. The trim is a difference between the depth from of the bow and of the aft. That's the trim. And how this can happen? Maybe because the vessel it's more loaded on its back side, so that's a trim. Sea waves. Sea waves are waves that are generated where the wind's blowing. So usually they represent a chaotic state of the sea, and they will be the waves that are inside these squares that you can see in the picture. Those squares are made of swell waves, something that I'm going to explain a little bit later, or maybe just now. Swell waves are waves that have been escaped from where the wind's blowing, so are well developed waves and have more or less a similar height and period. A sage, it's a standing wave in an enclosed or partially enclosed body of water. What it means that they're gonna exist two waves that flow in opposite directions, but they have the same period. So this can happen, this phenomenon. As you can see, there are points that do not move up and down, but then there are points where the amplitude is twice as for a single wave. So if you're in a harbor or in a port, you have to take those waves into account, or this phenomenon into account, because if the ship it's not in a node, it's in the place where the amplitude it's double, then you're gonna have trouble. Okay, fetch is the length of water over which a given wind has blown. So it's usually measured in kilometers or meters. A fairlead is a device installed on the decks of the vessels that are used to guide a line. A winch is a device that is used to pull in or let out the lines. And a tail, it's the end of the line. And now we're gonna start properly to explain how OPTIMOOR is used. It's gonna be long and tough, so be prepared. Once you open OPTIMOOR, the first thing that appears is this general environment window. But I'm not gonna start explaining this window because I found out that it's easier to start from some other window, that is the Berth data window. So let's begin. Something that you have to take into account with OPTIMOOR is that OPTIMOOR measures the angles or the directions of the waves or the winds with a particular direction of the north. That is, OPTIMOOR understands that the north, it's facing the right side of the screen, as you can see here in this drawing. So this is the first thing. OPTIMOOR asks us to define where our north is, related with that left to right direction. So if our north it's oriented not in that particular direction, left to right, we have to define it here at the beginning of the program. Then OPTIMOOR asks us the width of the channel and the pier height. Also, OPTIMOOR asks us the dredge depth below datum. And why OPTIMOOR is asking us the width and the depth below datum, or the width of the channel? Because that affects on how OPTIMOOR has implemented how the currents affect the vessel. So if the channel is wide enough, or you are not working in a channel, you maybe your deck is just facing the open sea, so you should give at least 5 times the breadth of the vessel. So if you're working in open seas, define this width of the channel as at least 5 times the breadth of the vessel that you're analyzing. The same with the dredge depth. If you're really in deep waters, how is it defined, or how OPTIMOOR understands deep waters? This depth should be 3 times bigger than the draft of your vessel. If not, OPTIMOOR starts to do some calculations of how the currents affect the vessels if the depth, if you're in a shallow water conditions. Then what you define is the permissible surge excursion, or the permissible sway excursion. So here you define what is the maximum allowable movement of your ship. Also, you can define the permissible vertical movement, the maximum. So if by chance your sea conditions or your load conditions makes your vessel move more than these distances that you have defined here, the program is going to issue a warning, so you will know that something wrong is happening. Then you have to define the distance of the berth target to right of origin. What does it mean? That means that you have to define where is your point of interest. Maybe you're more interested to know what is the movement at the middle of the vessel, or maybe you're interested to know what is the movement at the bow of the vessel. So you have to define here, it's a relative distance. So as you can see in the drawing, there is a black line called short target. So when you define this distance of berth target to right of origin, you're defining the distance between this short target to the point of interest in your vessel. Then OPTIMOOR asks you to define, you're gonna introduce wind data in OPTIMOOR. The thing is that if that wind data hasn't been obtained at 10 meters height, then that wind should, well, needs to be corrected. So that's something that OPTIMOOR does automatically. So not probably, but maybe you have winds measured at 22 meters height. So you can input those winds, but you have to tell OPTIMOOR at what height those winds have been measured to let OPTIMOOR to do the correction. Then, we're going to the right side of the screen, OPTIMOOR asks us what is the high water level or the tides. High water level, low water level, and the time lag. What does this mean? This means that if you don't have a tide table, that's highly recommended that you use, you can introduce that tide table in OPTIMOOR, or if you don't have it, maybe you're working with an Admiral chart or something, you can input here the high water level and the low water level, and then the time lag. And what does it mean? Maybe your data, your tide data, is measured in a point that it's a little bit far away from your point of interest of where you're working. So this allows you to define what is the time lag between that point and your point of interest. How long it takes for the tide wave to arrive from that point that you have data from your point of interest. Then OPTIMOOR asks you what is the velocity of the current and the direction in both situations, in ebb and in flood. Also, there is something here called time lag at slack. That means that OPTIMOOR is asking you what is the delay between when happens the maximum current velocity and the maximum tide, or the highest tide or the lowest tide level. This is a complicated parameter that probably if you haven't performed a survey to measure this is going to be a little bit tricky to feel, but it is what it is. Anyway, then you're gonna define where are your bollards. Your bollards are identified in OPTIMOOR by capital letters, as you can see, and blue dots in the drawing that appears on the right side of the screen. So here you're gonna define the position of the bollards depending on where have you defined this black line called short target. So as you can see, on the left side of the short target there is like negative numbers, and on the right side there are positive numbers. Then you're gonna define what is the position, like the vertical position, the Y position, like the Y coordinate of the bollards, by a relative distance regarding the fenders. So well, the front side of the fender, the part of the fender that is in touch with the vessel. So and it's positive facing up the screen. So well, here you can see the bollard A is a minus X, the X coordinate is minus 200 and the Y coordinate is plus 35. Then you have to define at what height those bollards are. So for example here defined at 1 meter, and what is their maximum allowable load. Then you have to define the fenders. Again, the X position, it's relative to where you have defined your short target. Then you have to define what is the height above datum. This is the height of the whole fender, and then the width, define the area too, and then the loading curve of the fender. You can obtain this from a catalog, or OPTIMOOR gives you some ideas, but it's as you're gonna have probably a really very specific fender, it's gonna be good that you fill this table with the numbers that you have from your catalog. Once you have filled this berth at the window, we're gonna go to, oh well, I forgot to explain this. Yes, if you don't really know what is the permissible surge excursion and the permissible SWI excursion, BS6349 table 3 gives you some values that you have to take this into account. This is the recommended values for the permissible search and SWI. Okay, once we have filled that table, we are gonna go to the general environment window. Here we're gonna define, as the title says, the environment parameters. First, we're gonna define when we want to start our analysis, at what time and at what date, and when we want it to finish. We can define this by times and date or by time lapsed. So it's gonna change if you modify if you set up the initial time and date, and you define afterwards the elapsed time, then the final time and date is gonna change based on this elapsed time. And then you define where or when do you want your results. So for example, here I'm analyzing from 7 a.m. the 1st of March of 2007 till 1 p.m. 6th of March 2007, but I want the data or the results at 9 a.m. the 1st of March 2007. What is important? Because if you had introduced a tidal table, then lots of things are going to change based on that tidal table. So that's why it is important, to introduce a tidal table, because OPTIMOOR takes that into account in its calculations. Also, OPTIMOOR asks you for the draft and trim at the initial setup and the final setup. Why this could have changed? Because maybe at the beginning of the analysis the ship was unloaded, and at the end of the analysis the ship was loaded. So these parameters can change at the beginning and at the end of the analysis. Something that I haven't explained is that blue numbers means input numbers and black numbers means results. Also, what else OPTIMOOR asks us here? Side of vessel facing up. Here you define if the deck of your harbor is facing up or facing down. Here is facing up, so it's like a standard something. Here OPTIMOOR asks us vessel offset beyond berth target. Here is asking us again what is the relative distance between the target, the short target, and the point of interest of our vessel. Also here is telling us that 4 fenders are in touch with the vessel at this particular time, what is the lowest bottom clearance, and the present clearance under keel. Then you define the wind, the mean wind speed, and the wind directions. How? Well, here it says from true or from angle berth line x-axis. So this depends if you want to define the direction of the wind depending on that particular north definition from left to right, or if you have changed that north, then you can introduce the value in some other way. So what they are here equal, because as I haven't changed that definition of the north, then the left to right definition is still valid. But if I will have changed that left to right angle, then how to explain this? Then this will vary because I'm gonna try something. Draw something. Imagine this, left to right, and this is north. Then this is telling me that this is 30 degrees. So no problem with this. But Imagine that I have changed my north from being this to being this. Then this angle to berth line x-axis will be, so if the wind comes from here, then this angle to berth line axis will be 90 degrees. But wind direction from true will be 0. Understood? This will be something like this. If you change one of the numbers, the other one it's gonna change based on what is your north definition. Okay? So, well, sorry for this, but I needed to explain. The same with the waves. Here you introduce the significant wave height, wave direction, and again with the same criteria of how you have introduced the winds. For swell waves, you have to do the same. And if you have data of the current, you're going to introduce that also here. Just imagine, where it says harbor, sage, and surge, you have to define. Do you remember when I defined this sage phenomenon? Then, if you're analyzing the inner side of the harbor, and you know that these sage waves can happen, then you have to define here the parameters of those waves. Also, OPTIMOOR allows you to introduce some other force, like, I don't know, maybe you're considering if a ship hits another ship, and you have the load that's going to transmit to the fenders or to the bollers, then you can introduce those data on the bottom right side of this screen. Also, if you don't have wave data, you can OPTIMOOR allows you to estimate a sea state. So if you introduce a wind speed, a fetch, and a duration of the storm, OPTIMOOR calculates what could be the waves that are going to be generated by that wind. Also, as you can see, as I now introduce some wave data, now the lowest bottom clearance is negative, because now we have a wave height of 6.82 meters. So, well, that's affect to the clearance of under the vessel. Once you have filled this general environment window, you're gonna define the characteristics of your vessel. It's a vessel data window. Well, here you can define the name of your vessel, the length between perpendiculars, the breadth, depth, and target. This again, OPTIMOOR sometimes asks you several times for the same parameters, and they are updated on the other screens that you have been working with. So if you modify some parameter here that affects some other screen, some other window, it's gonna vary in that window too. So don't worry about it. You don't have to be changing everything everywhere. Then you have to define the kind of bow end that you have. This is based on the OCIMF manual, so I recommend you to have it close or buy it or check it online, because you need that to define how is the bow of the vessel that you're defining. Also, here it's asking you this, where it says fender limit, aft fender limit, what it's asking you is to define, if you click on those numbers, what is going to appear is something like this. It's going to appear, this will be your vessel, okay? So OPTIMOOR allows you to define those points, okay? So you can define how is the transverse side of your vessel. I don't know what those numbers mean, but if you click on them, there is a table is gonna appear where you can define the shape. Again, sorry for the explanation and for this. Then, what OPTIMOOR asks you at the next number is what is the area above the deck and what is the area on the side of the vessel. Also, at the next thing that you have to define is what is the maximum radius of motion per unit significant height of. Okay, what it means that if you haven't introduced because you don't have wave data, then you can tell OPTIMOOR to calculate what it will be the worst case scenario. So what that means, 0.3 means you have your winch here. This is the deck of your vessel. You have your winch here, and you have a boiler here, and you have a line between them. What you are saying is that OPTIMOOR is gonna move this winch in this radius, well, this radius in this radius 0.3, and it's gonna find the worst position of the winch, and that's gonna simulate the effect of waves. But you have to define how much you want it to move. So for example, if you define this number really big, you're gonna have really, well, this position here will be like a really bad position. So it's something that you have to think about a little. Okay, let's clean off this. Fine. Cool. Now, what you have to define in OPTIMOOR are the lines. The lines are identified with numbers, and you have to introduce what is the fire lead or where related with that target that you have defined before. You have to define the height above the main deck and how far is that fire lead to the winch. Also, you have to tell OPTIMOOR if the lines are in pre-tension, the line diameter, also the type of the line, the material, if it's polyethylene or is another kind of material, the strength of the line, the length of the tail diameter, the type of material that it's made of, the tail, and the strength. Also, OPTIMOOR allows you to define the strain and tension curve for the lines. Maybe you're using some other material that OPTIMOOR doesn't have it implemented, and so you can define your own if you don't find the one that you're using in your design. So you can define your own curve. Also, if you don't really know what could be the breadth, depth, and length between perpendiculars, BX6349 table C1 gives you a table where you can find like standard parameters for different kinds of ships. So this will allow you to feel a little bit, well, if you're, I don't know, doing like pre-calculations or everything, and you don't really have the parameters of the vessel that you're analyzing, you can use this table. At the end of the story, you're gonna have something like this: boilers, fenders, winches are defined by these red dots, the lines are those ones in black, and here appears the direction of the wind and the currents. Then we're going to define how the lines are linked with the bollards. So here appears the lines. For example, line 1 is going to be linked to bollard A, and we can see here line 1 is linked to bollard A. So the rest with the other lines. Here we can define if there's going to be some pull in, so to put the line in tension. Then OPTIMOOR calculates the total line length, the inclination, that it shouldn't be more than a 15 degrees or 25 degrees. Then OPTIMOOR tells us if the lines are in tension or are, it cannot be, but in compression, and the percentage of the strength, that it shouldn't be more than a 55%. Then it's telling us the parameters of the fenders in this condition, so the pressure that the fender is suffering, and the compression, and everything. And also, at the bollard is telling us the total horizontal force that the bollard is suffering. Well, the total, the X force, the Y force, and the direction. During the analysis, OPTIMOOR is gonna check this, and if something is going wrong, it's gonna show you here. For example, if the percentage of strength it's bigger than this 55%, then those numbers are gonna turn red. Or if something's wrong defined, here's gonna show in red. So for example, if the force, as we have defined that the bollards had a resistance of 200 tons, so if the force, the total applied horizontal force is bigger than 200, here is going to appear in red. Something really interesting in OPTIMOOR is that OPTIMOOR gives you this wind limit rows. So what appears here? Here appears in what conditions the strength of the bollard is reached. So for example, this red line means that bollard D with a wind of 120 degrees direction and of more or less 120 knots, bollard D is gonna suffer the line is gonna reach its 55% of strength. So you have to take that into account while designing or while giving advice to the pilot of the ship. So here appears the line strength and when the bollards reach the 200 tons limit that we have defined, 200 or whichever number we have defined. Also, OPTIMOOR tell us, well, it's a similar graphic, but based on the current speed. It is the same when the bollards or the fenders or the lines reach their limits, depending on the direction of the wind and the wind velocity. I hope that I have been clear enough. Sorry for my English again, but I think it's clear enough what I wanted to transmit you. If you have any questions, please make a commentary on YouTube or in my website, and I'll try to answer. Have fun. Bye.